Okay, good morning class. Alright, so at this point we were looking at quadratic equations and inequalities. Not so. You guys have had homework, correct? And the homework was on exercise 2.4. 2.4, yep. So you had to do 2.4 the even numbers, correct? Right. 2.4 the even numbers. Just get a textbook. Which page was that on? 28. You had to do the odd numbers or even numbers? Both. Any issues there? Number 9. Exercise 2.4, number 9. Any other problems? Okay, so the question says you must write it in the form of a open brackets x minus p squared plus q, which is also known to us as completing of the square form. Okay. So what's the first thing we need to do here later? Since you had the mistake, so you read out your answers there. So I can try and pick up your error. Go for it.
So I tried to divide it by minus 1.
Negative 1. Did you mistake already? So now if you're looking at the exercise, what did you divide this by?
2.
And number 8?
2 as well.
2 as well. Now if you look at number 2 you divide by 2, number 8 you divide by 2, number 5?
So I was, at first I was thinking, okay, I'm going to divide it by minus 3.
No, minus 3 is correct. Remember what was the rule I said when we did this? We must divide or take out the common factor of the whatever the coefficient of x squared is. You must take that out as a common factor, irrespective if it's common throughout. You understand why? Why do we do that? We do that so that we can have a 1 in front of x squared as the coefficient. So if we take out negative 3 as a common factor, what are we left with? X squared plus x over 3, yes, so it's a third x. 1 divided by negative 3 is negative a third. Okay. So what's the question we should be asking ourselves? We must add a number to complete the square with and subtract the same number. And what is the number in this case? It's a third times a half. This must be times a half, and it must be squared. So it's a third times a half squared. A third times a half squared. So it's going to be 1 over 6 squared, which is 1 over 36. Okay. So here's our perfect square trinomial. So what do we have now? Negative 3 into x plus 1 over 6 squared minus 36 is going to give you 12. Should be 13 over 36. Negative 1 over 6, 36 minus a third. Negative 13 over 36. So what do we do now?
Multiply
Multiply the negative 3. negative 3 into x plus 1 over 6 squared plus 13 over. You understand? Any other confusion with exercise 2.4? So you all understand. So your next subheading is maximum and minimum values. Maximum and minimum values. And this is on page 28. Okay. So at this point we are told that every trinomial, which is ax squared plus bx plus c, equals 0, where a is not equal to 0, as a maximum or a minimum value. So they're trying to say that any quadratic pattern has either a maximum value or a minimum value. Okay. When will a quadratic have a maximum value? This we did last year. When will a quadratic have a maximum value? Okay, what graph do we draw when we draw a quadratic graph? Parabolas. Not so? And the parabola that you drew last year was in the form of y equals ax squared plus q. Not so? Or y is equal to ax squared plus c. So now we're introducing a bx2. Okay? But we're not at that point yet of drawing the parabolas. But when would the graph be doing this? When the what? Okay, one at a time. You all are saying the same thing. But different things, sorry. Yes? What is positive? Your a is positive, yes. If a is greater than 0, or when a is positive, the parabola is smiling. Or it will have a, what we call this? A minimum value. Not so. Like a note thing. If a was less than 0, then the graph would be sad, yes. Or is also known as a maximum value. Not so. So the graph had a minimum value when it was positive. If a was positive, at a minimum value. And if a was less than 0, which means to say a is negative, you would have had a maximum value. Do you all understand? Right, that was this basic revision. Now, we are told that every trinomial ax squared plus bx plus c, where a is not equal to 0, if a is 0, then this won't be a trinomial anymore. Then you would have had just bx plus c. Not so. So he has to say a can be any value besides 0. It has a minimum or a maximum value. It is possible to determine the maximum minimum value by completing the square and writing the trinomial in the form of a open brackets x plus p whole squared plus q. Okay, have we worked with a into x plus p or x minus p? It was normally x minus p, isn't it? From yesterday's, not yesterday, but the previous lesson, it was always plus, 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 plus. Okay, normally we write it as a minus, but it doesn't change the value of anything, okay, or the understanding of anything. The same thing, just written differently. Okay. So the first question, write down the maximum or the minimum value of the fund. So later on, okay, when we start drawing the graphs, okay, then you will see how this actually becomes the turning point. Okay, but at this point we're not drawing the graphs. So what we're going to do is I'm just going to do it lightly and give you an idea of what's happening. You see, this is positive. So the graph is going to be have a minimum or a maximum value. There's a minimum value. So this turning point here can be read off from here. When we do graphs, I'll do this on the graphing program and you can see the link between it. Okay, but for now, we're just going to accept it as it is. Okay? You see A is positive, so the graph is smiling. So this turning point here, its coordinate, is going to be positive 1. Sorry, this is positive 1, so it's going to be negative 1 and negative 4. The question is write down the minimum or maximum value of each of the following. So this graph will have a minimum value of, what's the minimum value? Negative 4, yes. And occurs at x is equal to negative 1. That's your answer. They didn't ask you all of this here, but I'm giving it to you all one time. And this is how I want you to answer. It has a minimum value of negative 4 and it occurs at x is equal to minus 1. Remember, if this had to be minus 1, then this would have been, what? Positive 1. Okay. Okay. Okay, next one. Number 2. What do you think this one would be? Smiling or frowning graph? Smiling. What will the coordinates of the turning point be? Positive 3 and 5. Not so? Now you write for me the story and what do you think it would be? Okay, so what would this be? Maximum, minimum? A minimum value of 5 and occurs at x equal to. Let's look at the next one. What would this be? Sad graph, also known as maximum. The coordinates of the turning point would be what? Negative 2 and 3. Okay. I think I must draw the graph for you now quickly and you can see. Okay, so We said there's going to be a minimum or maximum? There will be a maximum value of 3 and occurs at x equal to? Do you all understand? Okay, let's just draw the graph for you quickly. The equation of the first graph was x plus 1 insert x plus 1 squared so I'll give you a chance to answer number 4 and 5.